An important feature about your course is designing how you can teach the concepts you are learning. If you go through your course outline, you realize that again and again, the designers of your course outline want us to help you draw a concept map to explain the concepts you'll be teaching in future. So I'm going to use this video lecture to lead you through our journey so far. In mechanics, we started with elasticity. That's a separate topic, but we started kinematics and we've come so far to dynamics, and we are going on to work, energy, and power. So I want to lead you through the various stages of the discussion so that you can get a clear picture of where we are coming from and where we are going. And I'm going to do so with a concept map charts. So these are going to be our aims: to illustrate the development of concept map for mechanics, then narrate a story to explain the relationship among concepts in mechanics. Now, we started talking about the kinematics when we addressed the issue of position. By now, you should easily understand that every particle, every object can be identified with its position or location, a particular point that particle will be at any given time. So at an instant of time, every particle will be at a particular position, and it can never be at two positions at the same time. Indeed, it's only in the magical world or the spiritual world that something like God, Jehovah, can be in several places at the same time. But in the physical world, every particle will be at a particular point at any given time, though its position can change. It can move from one position to the another. That's what is illustrated here. So if an object changes its position, then we say it has moved. It is in motion. It is moving. And there are several terms we can use to describe motion. In that case, we are talking about kinematics. The first concept to describe motion is displacement. That answers how far is the object's new position from the initial position. Is it near? Is it far? We can answer that when we are able to determine the quantity called the displacement, which is a vector quantity. If we are only interested in the magnitude, then we'll be talking about the distance. Okay. Coupled with the time taken to move from the original position to the new position, we can obtain another quantity called the velocity or the speed. So if we divide the distance traveled by the time taken, then we obtain what we call the velocity of the object or the particle. Now, the velocity itself can also change. If the velocity of the particle, a moving particle, changes, then it will do so over a period of time. If we divide the change in velocity by the time taken to change from the initial to the final, then we obtain another quantity called the acceleration. So this outline tells us, describes the various terms we can use to describe motion, the motion of a particle. So we are indeed describing the motion of a particle. If we are having a lesson that describes motion of particles, we are indeed talking about kinematics. We went further to make a justification. Why will objects change position, or why will objects change their velocity? So we made the case, or before then, we came out to the mathematical relationship between the three quantities. That's the displacement, the velocity, and the acceleration. There were three equations that we can use at any particular time. These equations remember, they hold actually for uniform acceleration. If the acceleration itself is changing, then we can't use this relationship. This is simplified for uniform acceleration. If we use uniform acceleration, then we will be able to use these equations to solve so many problems. Now, we needed to also explain why objects change their state of rest or motion. In other words, why do objects accelerate? And to help us explain acceleration or change in the state of motion or rest, we relied on Newton's laws of motion. And the first law was about inertia. The inertia focused on the position of the object and its velocity. You see, what the law of inertia, the first law, is saying is that an object will remain at its position where it is at rest. Or if it were moving, then it will want to maintain its velocity. It doesn't want to change its direction. It doesn't want to change its speed. Is that okay? It will want to maintain these two important quantities unless something happens. And what will cause it to change any of these two quantities will be the force. So before an object accelerates, a force may have to be applied to it. Indeed, it is an external force, and that force must be a resultant force. Several forces may be acting on it. If you sum them up, there should be a resultant one. That will be the effective force acting on it. That's what we call the resultant force. And that force, according to Newton's second law, is directly proportional to the acceleration. More acceleration, more force. That's what the second law is telling us. The second law also tells us that an object accelerates mainly because there is force applied to it. So get that point in mind. The third law was about action and reaction pair. We are not going to say much about that in relation to what we are doing now. Now, if you could remember, we also found another route to obtaining the force. Thus, if an object is moving, then we can derive another quantity about the object that we call the momentum. It's simply the product of the velocity and the mass of the object, and that will give us the momentum. This momentum can also change with time. If the momentum changes with time, then the ratio of the change in momentum with time gives us the force. So indeed, instead of going through with the change in velocity, giving you the acceleration, and then finally multiply the acceleration by the mass to give you the force, we can also obtain the momentum, compute the change in momentum divided by the time, and that will also give you the force. So just keep those pictures in your mind that this were what we are actually doing. You can go back to the videos and you link them to this map that we are going. Now, the final question I would like to ask is, so we are now considering, we are done considering forces, and where are we heading to? We are going to multiply forces by the distance it causes other object to move through, and that will give us another quantity we call the work done. Work done. So if we multiply force, if a force pushes an object through a distance, then we say the force has done work, and work can be quantified by multiplying the force by the distance it has traveled through. That's what we are going to talk about this week. Then eventually, how much time do we take to do a particular work or a certain amount of work? That one can also be answered by calculating what we call the power of the energy being transferred. So we are going to talk about work done, energy, and then power in the next lesson. All right, so this is a concept map of what we've been doing. Just take a clear view of it and then go back to the videos and see how they relate to the video.